Okay, so we're working on answering the question of how do we know where to round to when my calculator gives me that monster long answer. Well, there's a couple skills that we need to be able to do before we can answer that question. One is to be able to look at a measurement and be able to tell which digits in that measurement are significant and which are not. We call these sig figs, and we're trying to figure out how many sig figs a number has. Now remember, when you make a measurement, all of the digits that you are certain of plus the first digit you guess at is considered a significant digit. So if I am using this graduated cylinder to make a measurement, I would look at it and I might come up with a good acceptable answer of 36.5 milliliters. Well, looking at that, I'm certain of the 3. It's definitely between 30 and 40 milliliters, and I'm certain of the 6. It's definitely between 36 and 37 milliliters. And we can eyeball it. It looks like it's about halfway, so I might say that it's 36.5. Now that last digit is a guessed digit, but it is still considered a significant digit because it's not just a wild guess. I can see that it's pretty much halfway in between, so I know that last digit, it's maybe 0.5, maybe it's 0.4, maybe it's 0.6. So it's not just a meaningless number that I guessed and threw there. It is a significant digit because I'm either sure of it or I have a pretty good idea of what it is. So in this case, this measurement that we have here has 3 significant digits in it, or in other words, it has 3 sig figs. Now sometimes being able to tell how many sig figs a measurement has is very easy. If your number does not have zeros in it at all, then life is easy because all non-zero digits in a measurement are significant. So in this case, the 65.346, there's no zeros. I've got 5 digits in that measurement. I've got 5 sig figs. Piece of cake. Now it's not always that easy. Zeros are the troublemakers, and the reason why is that sometimes zeros are significant digits, meaning that they are part of the measurement. They're a part that I'm certain of, or they might be that first guessed digit, in which case they're significant. But other cases, zeros are there simply as placeholders. We need the zeros to either make the number that big or to make the number that small. Now to understand this difference, let's think about Beaver Stadium at Penn State. Now, Beaver Stadium has 106,572 seats. So let's say we were looking at this picture of Beaver Stadium on this particular day at this particular game, and we wanted to measure how many people are at the stadium. Well, we can look at it, knowing that it holds 106,572. We could look and say, well, it's pretty full. I don't see a lot of empty seats. There are some empty seats there. So we might come up with a reasonable answer, a reasonable measurement of 105,000 people at this stadium right now. Now, if we think about that answer, we can be pretty certain about the 1. Okay, definitely, there's not a lot of empty seats. I'm pretty sure there's more than 90,000 people there. There's certainly not 110. Can't hold that many in the stadium. So I'm pretty certain about the 1. It's definitely not 200,000. I'm also certain about that 0. Like I said, it's not 90. Not 110,000, so I'm pretty certain about the 0. And, well, it's pretty close to full. I know 106 is full. It's a little bit less than that, so I'm guessing at the 5. So in that measurement, I have a couple digits that I'm certain of. I have the 5 that I'm guessed at. Remember the guessed digit, that is significant. Now I have those other 3 zeros at the end. I have no idea whatsoever what digits should go there. You know, maybe they're 4s or 7s, 3s. If I put any numbers in there, if I said 105,472 people are at the stadium, you can look at me and just tell me I'm full of baloney because I would have absolutely no clue about the digits that go in these places. So I just put generic zeros in there. I need the zeros. In this case, they are place-holding zeros. I'm not saying that's what the number is. They are simply there to keep the number that big. We're talking about 100,000 people. Okay, so I have to have those zeros there to keep the number in the 100,000s. So in this particular answer, it's kind of interesting because I have 1 0, my first 0 here. That is a significant 0. But the other 3 zeros on the right, those are just simply place-holding zeros. So how do we know whether zeros are significant or not? In this case, that has 3 sig figs. Well, there's a couple ways to tell. Now, one quick and easy way is if your zeros are sandwiched, then life is easy because any zeros that are sandwiched between 2 non-zero digits, they're always significant. So if I have 4,005 as my measurement, maybe it's 4,005 grams, well, the zeros are sandwiched between two non-zeros, so every digit there is significant. The two that are sandwiched are, and the 4 and the 5, of course, are. So I got 4 sig figs in that measurement. If I had this measurement here, now in this case, the two zeros on the left are sandwiched between my 8 and my 4, so they're significant. The other 3 zeros are not. They are merely placeholding zeros, so that number has 4 sig figs. You can even have them spaced out. In this case, I still have these 2 zeros. The 0 on either side of the 5, those are both sandwiched. The 2 at the end are not, so that one has 5 sig figs. So if I have a sandwiched 0, it is definitely significant. But what about the zeros that are not sandwiched? They're a little tricky. Now, one way you can always tell, this is a nifty little trick and that always works, is to use something called the Atlantic-Pacific rule. I can use it to tell whether zeros, or really any digits for that matter, is significant. It's a good test. Now, in order to use this rule, as you can imagine, I might need to know a little bit of geography. So I look at my number, and I imagine my number superimposed over the United States. Now, this is where the geography part comes in. You need to know which side of the United States is the Atlantic Ocean and which side the Pacific Ocean is on. So given that information, you can use the Atlantic-Pacific rule. You've got to look at the number and you have to ask yourself a question. You always start by asking, does my measurement have a decimal? In which case, you're going to have one of two answers, either yes or no. So let's look at the case that yes, my measurement does have a decimal. If a decimal is present, what you are going to do is you're going to start on the Pacific side of that number. Okay? Present Pacific. We made it easy to memorize. So what you're going to do is you're going to cruise across the United States, starting from the Pacific side, and you're going to cruise through zeros until you hit a non-zero digit. Okay, a non-zero digit, in this case the 4, is going to stop me. I can't cruise any farther than that. Okay, now when I do that, all of the zeros that I cruise through, those are not significant zeros. Those are just placeholding zeros. In this case, those zeros were just there to keep the number that small. Now, from that point I stopped, everything from that point on, the rest of those digits are all significant. So obviously the 4 and the 3 are, the 0 that's sandwiched definitely is, but those 2 zeros on the end, on the far right side, those are significant zeros. So we can look at this measurement here and say this number has 5 sig figs. Okay? Now, anytime, let's look at another example. Okay, if I look at this number here, so there it is, I'm imagining it over the United States. What's the first question I ask myself? Does it have a decimal? In this case, my answer is no. A decimal is absent. Well, if a decimal is absent, I'm going to start from the Atlantic side. So I'm doing the same thing, just coming from the other side. I'm going to cruise through the zeros. I'm going to go until I hit a non-zero digit. In this case, the 3 is going to stop me. And then the same deal. All the zeros that I cruise through, those are not significant. And then from the point where I stop, everything from that point, in this case from that point to the left, those are all significant digits. So this particular measurement, 403,000, written as it is, has 3 sig figs. So remember, you can always use the Atlantic-Pacific rule as a quick and dirty way to tell how many sig figs a number has.